Hello, everyone. Thank you for coming to today's webinar, Requirements Engineering for Software-Defined Vehicles. Your presenters today are Nikhil Unikrishnan, Juan Webb, and Greg Gruska. If you have any questions throughout the webinar, I kindly ask that you type them in the chat box, and we will address as many as we can at the end of the webinar. We also encourage all participants to complete the survey afterward. Your feedback is greatly appreciated. If you would like a PDF copy of the presentation or the webinar recording, please contact us at webinars@omnex.com. Nikhil Unikrishnan is the Director of Consulting with extensive experience supporting automotive and semiconductor organizations in hardware, software, and mechanical system development, helping implement best-in-class practices aligned with ISO 26262, Automotive SPICE, ISO SAE 21434, and SOTIF. An INTAX certified principal assessor and certified lead auditor for IATF 16949 and ISO 9001, he leads assessments, training, and consulting initiatives at Omnex while playing a key role in advancing the EV/AV platform. Juan Webb is the Associate Director of Omnex's e-mobility services. He is a seasoned expert with over 30 years of multi-industry experience in regulated and non-regulated environments and has led complex electronics programs through every phase of development. As a certified ASPICE competent instructor, principal assessor, VW software quality improvement leader, and INTAX regional representative, he is deeply committed to advancing the development of safe, secure, and high-quality systems. Juan continues to pursue his passion for shaping the future of embedded systems through training, assessment, and strategic influence. Greg Gruska is the Omnex champion for APQP, PPAP, FMEA, ISO 26262, and Lean Six Sigma, a fellow of ASQ and a globally recognized authority on risk management and functional safety. With a distinguished career at General Motors and key contributions to major IATF 16949 manuals, he brings decades of experience in quality engineering, systems reliability, training, and global industry leadership. Now, without further ado, please welcome Nikhil, Juan, and Greg.
So
You're
Juan,
on
you're on
mute.
mute.
Good. That was a test for everyone. I'm glad you guys all caught it. All right. So first, a little bit about Omnex. We're 40 years in operation, dealing with organizational and strategic operation consulting. We're headquarters in Ann Arbor with offices in Berlin, Chennai, Shanghai, and about 16 other offices globally. Over 900 employees worldwide, that's active in 30 different countries. And we're covering industries like automotive, aerospace, semiconductor, and medical devices. Um, we've done and worked with over 10,000 plus projects and trained over 500,000 individuals through functional safety, IATF, ISO 9000. And our SMEs that are with Omnex have over 40 years of experience in each within their industries. Next slide. So, oh, Nikhil, can we go back one, Nikhil? It's just to tell us a little bit about some of our experts. We're a company of thought leaders. We write and shape industry standards in a lot of the industries, including 26262, 21434, ISO 9000, SOTIF. Not only are our SMEs active within the industry, but they're also writers on a lot of the technical committees for these standards. So just wanted to highlight the expertise that Omnex brings to the organization. And finally, just to give you an overall picture of our global operation, as I said, we're in the Americas, Europe, and Asia Pacific. It shows our headquarters is in Ann Arbor, Michigan. So it just gives you a global picture of what Omnex looks like worldwide. And this shows our full range of expertise going from strategic and business transformation all the way through e-mobility, functional safety, cybersecurity, AI, and integrated product development. The focus of this area is going to be our e-mobility area, and that's what we're going to talk about today, requirements. So a little bit about the agenda. So we're going to talk about the traditional requirements management approach, and then some of the challenges, and then talk about AI-enabled requirements management processes. So if you're looking are interested in AI tools to support requirements management, this would be a good webinar for you. So make sure you ask questions at the end of the chat, and then we'll go through a summary.
Okay, this is Greg Gruska. Let me kind of put the focus on here. We're talking about requirements management. We got to identify what is a requirement. So just to make sure everybody is on the same wavelength, we're going to be talking about the product requirements. Now, product requirements are defining what is the system, what it must adhere to. So the system requirements define to the rest of the product and process development how to build the product into meet or how to build the product to meet the product requirements. Thing is that requirements need an acceptance criteria. Once we have a good requirement, and this has been defined or identified as one of the base elements in ASPICE, is that we need to have acceptance criteria. Now, when we're talking about the importance of criteria, we got to remember that it affects all aspects of the product and process development cycle, from developing the FMEAs to the control plans to coming up with what are the verification requirements and validation. If you have a good requirement, you essentially have the validation requirements clearly defined, and so forth. Now, this is supported and managed by the different ASPICE processes, and we'll show you that on another slide, how some of the processes interface.
Greg, thank you for mentioning that. So for it, just wanted to cover quickly. For those of you familiar with ASPICE, you know that we've recently had a change from PAN 3.1 to 4.0. And I just want to give you just a few important highlights. So for requirements, one of the changes in the text was that we went from having separate information for verification criteria, and they pulled that back into just the definition of a requirement, which we all know really that's where it belonged in the first place, right? It belonged in there with all requirements should be verifiable. That's part of a characteristic. And also one of the major things that they did, they pulled consistency and traceability back to one base practice so that because one serves the purpose of the other, right? You can't really have consistency. You can't really have consistency without getting traceability or getting some alignment with the different upstream and downstream activities. So just wanted to highlight that those were some key points that they moved from 3.1 to 4.0.
Now, the typical requirements engineering process is consists of 5 steps. The first is the obtain stakeholders requirements. This is the elicitation, and there are a couple of work or processes in ASPICE that deal with that. Then we have perform the requirements analysis, create system and other requirements, define or perform the requirements review, and then manage the upcoming revisions to stakeholders' requirements as we continue through the product and process development cycle. All of these are interrelated. and identified in different processes within the ASPICE realm. So here we have the basic ASPICE processes and how they relate to the requirements engineering process. So you see that they are covered by all the different ASPICE criteria. All right, you can go next slide, yes. When we're talking about requirements management, there are certain challenges, and these are what can be handled through software support of the requirements management. The misrepresentation of stakeholders' requirements, ever evolving stakeholders' expectations. So you get an agreement, and then after you're halfway through, the stakeholder comes in and changes. So how do you handle that? Incomplete or imprecise, which typically cause the second element to occur. Disagreement about priorities and importance of competing requirements, and reinventing the wheel, unable to leverage historical product development experience. All will affect the overall timing and throughput of the traditional engineering requirements processes, and they lead to several challenges. And Nikhil will talk about those.
Thank you, Greg. So Greg brought up a good set of challenges that we traditionally face with requirements management in general. And we had this few steps in the requirements management process. If you were to map challenges specific to these steps, what does it look like? One, it often, is in unstructured format. And sometimes you may be familiar with how you get a bunch of PDFs from your customer, and then you have to either copy paste into some kind of requirements management tools through manual type ins, and think about like 100, 200, 300 documents. It's a lot of time. When you think about like requirements analysis, this is again a time consuming analysis. Sometimes it ends up being incomplete. You have a hard time trying to establish traceability from stakeholder to system requirements, and also prone to human inspection error. And there, the next one, we have the situation where we may not always think about all those technical requirements. And then also to create new requirements is a time consuming process. It differs also based on the competency of the requirements engineering team, some more seasoned than the others, and how they're able to get on with it. And then again, in terms of review, time consuming review, there's also the knowledge gap here again as well, and also communications and team and other OEMs or stakeholders or suppliers you need to work with to make this happen. And then upcoming stakeholder revisions. Here, sometimes you get another version of those PDFs I mentioned. Now you got to compare every line by line, and then establish where the changes were made, and you have to update it back into your requirements management tool. That's again a lot of effort. So in total, if you think about all of this, if you were to think about time and cost, this can come around to like about $80,000 to $800,000, and again 1 to 9 months in terms of project complexity, just in pre-code phase. And then when you go into the post-code phase, you're talking about another $320,000 to another $680,000. Again, another 2 to 4 months based on project complexity. Now, this means, we mentioned about AI and how it could possibly assist. Without AI, requirements engineering, it can take anywhere from 1 to 9 months. And then also it's an expensive and time consuming activity, which may not address everything that we hoped for. So now, what if you could do something about it? That's where we are trying to say maybe technology such as AI can become of assistance to us in this journey. So again, against each one of those process steps, let's take a look at what happens. In terms of obtaining stakeholder requirements, you're talking about automated import of requirements, maybe in unstructured format. Requirements analysis, this is where you can utilize legacy knowledge of products to determine feasibility of new products. How easy and cool would it be if you could tap into all of those previous products you developed already and just reuse information from that rather than, as Greg said earlier, reinventing the wheel. And then, of course, automate requirements traceability. Creating system requirements and other requirements, this is where it gets interesting, where you're able to contextualize legacy product information and then be able to generate new stakeholder, new system and software and hardware level requirements based on that. So this is again going to be of help for us. And of course, if you think about review, again, you could automate qualitative and quantitative analysis where it can help you reduce risk, timing, cost, and also help you increase confidence in the project itself. And then, of course, maintaining changes. Here you can import revised requirements and make sure that you have those changes easily identified rather than through manual effort. And lastly, as a bonus, if you do it digitalized, this is where you can get integrated work product development. So rather than creating work products that are similar, you can create one, it transfers over into the next work product, and it's all integrated seamlessly. So again, you can bring down cost and time. So you can see, in short, it comes to almost maybe even less than half, you can say. So both in pre-quote and post-quote, there's considerable savings that you can have through use of newer technology, as example, AI. At this time, we want to take a moment to get your feedback and get your perspective. Andrew, if you could please assist with the webinar polls. Where do you see technology such as AI adding the most value in your requirements engineering process? Is it obtaining stakeholder requirements? Is it performing requirements analysis, creating system and other requirements maybe, or performing requirements review, managing upcoming revisions to stakeholder requirements, or maybe performing integrated work product development? Let us know your thoughts so that we can see, again, what all of our peers in the industry are also thinking.
And Nikhil, once we get the polls and before we move on, I wanted to address one question related to this, and then because I think everyone's probably thinking about it.
Certainly.
And that's really going to be the topic of what happens when your customer gives you something that looks very much like, for example, a software requirement within your system, and that's what they want you to deal with. Is there a method for within this type of setup to address that situation?
Clearly, you brought a valid point up where a lot of times your customer is giving you detailed software, hardware requirements, which you now have to then consider, right? And a lot of times this means you are building constraints into the design, which you as a tier one or the tier two may have had alternate solutions. But again, you need to take into consideration those requirements and allocate it at the appropriate level. So you have a valid point there and something we need to think about. Okay. So we have results in, so you can see performing requirements analysis and review. Those are the two places most of our participants here feel that AI can add value in. So interestingly, we can see lesser votes for creating requirements and also obtaining stakeholder requirements. That's an interesting observation.
Yes, it is. Considering that we're moving more toward software-defined vehicles, the number of requirements are going to increase significantly.
Yes, indeed, Juan. Yes. Okay, so we will just quickly take an example of what our team here has done in terms of creating requirements. Clearly, unfortunately, not the popular one in the votes. We had an example for each one of these steps, but we decided to limit it because we had only 30 minutes to one of them. So this one, if you take about creating system requirements and other level requirements, maybe let's first get some thoughts from Juan on this.
So thank you, Nikhil. So I think everyone's probably seen this the traceability diagram. So we've added a few things in here for hardware and mechanical, just to give the concept that both hardware and mechanical needs alignment as well. You need to perform traceability with that. One of the things I wanted to highlight is that one of the topics we always discuss is, why do we need so much? Why do we need it to be forward and backwards? So if we think about it, the forward traceability, what that does for you, that helps you understand that the requirements that you have been pushed through the system, through design, implementation, and test to make sure that things are implemented, verified, and validated, so that you're sure that every requirement is fully realized. And then if you going the other way, and that's even an important one. What that does, that makes sure that you don't have any unnecessary or unintended functionality in your system, right? Because if you have something implemented that you can't trace back to a requirement, right, that tells you that you have something that you might not need in the system. It doesn't come from a need that's been defined early. So that's what this diagram really does for you. It helps you understand, whether your system has been built appropriately or not.
All right, following up on that, because we're talking about the being effective and efficient in designing the requirements, we've got to realize that we have a requirements flow down. In other words, we at each level of the V model on the left-hand side, as we are going down, the requirements at the lower level have to support the requirements at the higher level. That is the reason why at each stage of the V model, we have the verification activities. Verification is done on the left side as well as the right side. Verification in terms of doing reviews and analysis. The right side is predominantly testing when we're doing the verification. So as we have to realize that going down, as Juan has said, that the requirements at the lower level have to be traceable to our requirements at a higher level. In the past, we had problems where the customer came in to a second tier or third tier and gave requirements or even gave components, unit software at the lower level that may not have anything to do with the ultimate requirement for the product. So we've got to recognize that we have this flow down relationship.
It's a good point that both Greg and Juan stated. So, one of the things we tried to bring into this picture is how you could leverage data from legacy programs going into new programs. Again, not just at one level, but at those levels that we saw in the V models in those previous slides. So let's say we have existing legacy program A, which has, let's say, A1, A2, A3 as stakeholder requirements. And now you have system requirements A1 and then 2.1 and then 3.1 also right next to it. You also have some hardware requirements and you also have some software requirements. And then let's say you have a new program B that you won inside your organization. So what could you do about it? So, well, here you got a different set of stakeholder requirements now, B1, B2, and B3. And then today, traditionally, you go line by line. An engineer would ideally identify if something is similar or not. And then if it is similar, then you determine if it's something you can reuse. Now, if you could automate that, then, well, you can the evaluation of the reuse can be automated, and also you can bring in those requirements from legacy programs, avoiding rework. And then where you have new requirements for that new program, colored in violet here on the slide, those are the ones you can focus on using generative AI solutions, again, contextualized on legacy product information. This is an example of one of the things we done for, let's say, stakeholder requirement B2, where we are saying we're going to use generative AI for new requirements. And here on the left-hand side, you can see there's a requirement that just got highlighted saying max boost clock speed up, it should be up to 5.1 gigahertz. And then you are going to now, let's say, generate system requirements. That's what just got highlighted there. Now, if you do that, then you can use AI, and the AI gives you a set of options, again, considering legacy product information. And then the engineer is able to decide, it's like picking from a menu and deciding which ones should go with the product at the system level requirements. Those are now selected, and then you could repeat the same thing also at the lower level for your hardware, software, and other subsystem level requirements. Now, in the poll, we saw that performing requirements review was also a popular vote. So if you did use AI, let's say one of the things that we have to be cognizant about is that while it is going to help you, it is also going to pose a risk where you need to have human in the loop, and you don't just let it do its own thing and then come up with results where, especially if you think about safety and security critical systems, that is going to be a big risk, and you can have big problems thereafter. So yes, it can help you in creating potential new requirements, but again, human in the loop is something that must be a guardrail that cannot be skipped. Okay. All right. And also you can think about interfaces where, what are my orphan requirements for my airbag system? What requirements are not yet approved? What requirements do not have test cases linked to it? Think about like a conversation style option where you can also have all of these outputs coming in. It's one of the things we've done with our requirement slowdown EWQMS product, and something that, where we've been able to see some of this data happen in real time. Okay. And this slide, well, just to mention again, when you implement AI-based requirements management systems, now do you know if it considers context, or you're just getting something from the open internet? And of course, there's a lot of information security protocols to be in place. And if the AI does not know enough information, does it know to ask you so that it doesn't make its own assumptions? And can it also do the plan, do, check, act, or the learn and improve cycle over time with human in the loop? That is also something worth thinking. I pass the mic over to Greg to summarize key points.
All right. In order to kind of bring this to a end conclusion, if we take a look at the requirements management system, in order to provide support for that, we need to have an AI-enabled requirements management process that enables a faster cycle time from the 6 months and a few weeks, from 6 months to a few weeks, with savings ranging from $250,000 to $850,000. We want to improve the quality of requirements analysis. You can do that by having consistent analysis, ensure the requirements coverage and completeness, which are requirements within ASPICE. But from a cost standpoint, it is an easier reuse versus always do new requirements identification. Obviously, we can promote prevention or preservation of organizational knowledge, and it continues building up as we go through. It can be used for a tool for upskilling junior resources, because unfortunately, we don't have the expert available for every junior. Well, with a software support, we can handle it that way. All the requirements deployment initiatives must include the organizational context, which are learned from your own particular product. There is no such thing as a uniform product on the road nowadays. There is the hands-free support or the um, automatic driving on multiple vehicles. Every one of them is a little bit different. They all have the same goals. They all have the same final requirements, but their implementation is different. So we can just not pull one from the other. It does help fulfill requirements of the standards. We do have a proliferation of standards. In software realm, we got ASPICE, but we also have functional safety, cybersecurity, and so forth. So AI based natural language interface can promote better user interaction. So there is less of a learning curve on implementing and provide consistency among different developers as they were going through.
Okay. So as we end this, we're going to talk about, just to give you a call to action, just to remind everyone that this year we're having our second annual NA SPICE conference, and it's not just for SPICE, it's for functional safety, cybersecurity, the semiconductor industry. So we have our call for paper that's ending pretty soon, if we don't extend the date on this. But please reach out if you're interested. I'm taking care of the sponsorship and registration committee right now. Nikhil is handling the call for papers. So if you guys have any questions, you can reach out to each one of us to get more information. But visit the website. Nikhil? And just to mention a few of our other AI solutions for FMEA tool, audit management, AI agents, a PPAP reviewer, a lot of things that you need during the course of development. You can go to our website and get more information or reach out to us and ask more questions. And then finally, if you want a copy of our free pocket guide, just write us at info@omnex.com and we'll start shipping those out to you. Very handy device, very handy little booklet to remind you of, the different things in the model. Next slide for me. And we'll just talk about our courses that we have on our website. So upcoming in a very short time frame, the process expert and provisional assessor class. We have an understanding ASPICE and integration with IETF class coming up. So you can scan the QR code to get more information. There's also a 21434 class coming up in April. And then we also have 6949 and 27001. So these are all good classes for you guys to take, but you can scan the QR code to get more information. Finally, want to talk about this webinar is just part of a series of webinars. So coming up March 19th is another webinar on best practices in architecture design. And then next. And then we have another one on safety lifecycle management concept coming up on March 5th. And April 2nd, we have another one on leveraging organizational ISMS for product cybersecurity. So subscribe to the entire series and you can decide which ones you want to actually attend. But keep us in mind as we move forward through our series for driving excellence in software-defined vehicles. Also take the time to reach out if you have questions or if you have topics you want us to cover during some of these series.
Certainly. And also, as we conclude this, just a last note that we will be releasing the schedule for also Q2 and Q3 and the rest of the year for these monthly webinars. We are doing 2 webinars, as Juan mentioned. One's on the software-defined vehicle series and another one on the safe and secure one. So I'm sure most of you would find it valuable to be part of these sessions as we discuss various topics. As Juan said, let us know with your feedback if there are topics that interest you and that you feel more relevant. Write to us at info@omnex.com. We would be happy to consider them going forward. And with that, thank you, Greg. Thank you, Juan. And thank you, Andrew. Thank you for the webinar. And we can call it a wrap.
Thanks, Nikhil.
Thank you, everyone.
Thank you.
Have a good day.